Now I've loaded a 2-inch indium phosphide wafer. My information there says that it's 1.55 microns. So I'll put it in, load the wafer, and it says can't switch the vacuum on. Sorry, have no vacuum. Doesn't really need vacuum, just holds it in place to stop it spinning predominantly on the deceleration phase. So we should be able to get an okay measurement on this 2-inch wafer sitting on a 3-inch wafer chuck. So it's not particularly well mechanically gripped either. And this is our spectral mapping mode. So we'll go in there. We're running with the 980 laser at 50 odd milliwatts, which is pretty close to full power from this laser. So I've set this to a center of 1550-ish, a slit width of 100 microns. Of the 3 gratings here, the 150 grating is the best adapted for indium phosphide materials, long wavelength materials. The 300 grating is pretty much a gallium arsenide grating, and the 600 grating you would use if you wanted to look in detail for a FP dip on a VCSEL or similar. We have an InGaAs detector sensitive to about, 16, 17 nanometers is probably about the longest you'll realistically use, down to about maybe 900 nanometers. And we've got a silicon CCD, which will do about 400 up to 1100 nanometers. So we have a 2-inch wafer. I'm going to do a 1mm grid on there. I'm going very fast, 180 scan rate. The maximum is 200 on this instrument. I'm excluding the outside 4mm, and it reckons it's going to take 19 seconds to map this. So let's acquire a spectrum here. And so there we go. We've got a nice peak at 1552.2. It says. Now I'm analysing that. I have some analysis parameters here. I'm going to use a threshold analysis on this, and I need to provide it with a threshold of, let's say, 90%, and so it's going to find the peak as the midpoint at 90% of the maximum. So that will shift us nearly 3 nanometers on this peak, like that. But as long as we're consistent, that's just telling us what shape the peak is. So then we just hit start mapping. We can give it a wafer ID. It says G753, and that will automatically form the file name. The material is indium phosphide, but that has no bearing on the measurement, so I'll just leave it as is for now, and I don't really need to do those. So okay, so we'll move to the start of the scan. So it's been measuring in the center of the wafer there, and it's just rotating it round to get the flag in the right position. And as I say, this is a rapid map. And the kind of hourglass shape there, that's indicative of strain layers in the structure. It will reprocess that then on finalizing to give us a sensibly auto-scaled set of conditions. So we end up with an average of 1549.4, standard deviation of 0.15% on that. So yeah, and then if we unload, you can see how much it moved, and really it's very static in the center there.